Everybody who's in this should know why you're here. We're here to talk about CaRT. So some of the topics we're going to talk about, just to start, we get a lot of questions about how the data is organized, how it's set up. And the first few slides, I'm going to talk a little bit about just generic data warehouse modeling principles and how they apply to what we've done with CaRT, what Oracle delivered for us, and then how we've modified it. Then I'm going to talk about some of the key subject areas within student records. So as everybody knows, our data model is set up as a bunch of subject areas, which are then just related models of data. And for student records, there's a few of them that I think are most important. We also have some kind of supplemental subject areas that I think as time goes on, we'll probably get more use out of, but I'm going to kind of try to cover the main ones right now. Specifically, after that, I'm going to talk about the scholar dimension because we get a lot of questions about that, how it works, why some things cause duplicates and others don't, and just how it's set up. And since it is probably the key dimension within this whole system, because obviously we all need to know stuff about students, and the scholar dimension has that information. And then some of the questions that came up and issues that people have had, I'm going to talk through some of those. I'm going to kind of switch over to CaRT itself and maybe do some examples of how to answer some of these questions. And then we'll open it up for questions and go from there. So to start with data warehouse modeling, we got three kind of key concepts to understand just to make sure we're all speaking the same language. So the first one is a dimension. You can see on the screen, a dimension contains descriptive attributes used for filtering and grouping measures. So a dimension is basically anything at the university that we can describe. So we're talking about an academic organization is a dimension. Academic program is a dimension. Within academic program, for instance, we have different attributes. You have the organization that the program is associated with. You also have the last term that a student can be admitted to that program. You have what type of degree or award a student can pursue within that program. And then academic plan, academic sub-plan are other dimensions. But you can even get down to like a status dimension where we talk about enrollment, and an enrollment status dimension would have attributes about the student's enrollment status. Are they enrolled? Have they dropped? And then it'll have descriptive information about those status codes. A fact table is the table that contains all of the measures produced by just the business operation. So a fact table, an individual fact would be a class, grade, a units taken, things that we can count, things that we can aggregate on, things that we can measure. The fact table is the driving table for every subject area. So generally speaking, a subject area that we have is based entirely around a single fact table. And the important thing about that is the fact table establishes the grain of that subject area. So grain is the lowest level of the fact table. It establishes exactly what a single fact table row represents. So if you think about a fact table as a table, an Excel sheet, however you want to think about that, a single row of a fact table has information, and that row represents the grain of the table. We have for every fact table an item called an integration ID, and that integration ID tells us exactly what is uniquely identifies that row of a fact table. So for instance, term enrollment, the grain of that fact table is a term activated student. So a student, a career, and a term represents the grain of that table. If a student is term activated, they'll appear in the term enrollment table. Whether they're enrolled or not, the enrollment then becomes a dimension that's associated with that student. Other dimensions would be the program that the student is associated with. But the reason we need things like primary program is that if a student has multiple programs, that will break the grain of the fact table. The fact table is only the student, career, and term. If there's multiple programs, that would add another row to that fact table. So if we look at just a primary program within that career, it's still just one row for the fact table. And I have some examples here. So this general model, if people who've used BI-query, we had kind of a more visual representation of the model and the actual linkages. In CaRT, the subject areas are all modeled like star schemas. So in the middle, you have a fact table, and then around that fact table are dimensions that are connected to it. And then we associate one dimension to the other dimension through the joins on that fact table. So for example, we've got term enrollment. Term enrollment is the fact table. It has facts like units, cumulative GPA, a term GPA. The grain is the student's term activated record, one row per term activated student, career per term. And then we have a series of dimensions. As I said, enrollment status is the student enrolled, they're term activated, but are they enrolled that term? What program are they term activated in? What plan is associated with that program that they're term activated in? And similarly down to the subplan. So within student records, we have three really big key subject areas when we're talking about student data. And then we have a group of other subject areas that I think get used a lot, especially when we're talking about ordering classes, looking at what classes are available and when the classes are going to be. So starting when I think about like individual student data, I generally start at the academic plan summary. That's kind of the highest level of student records data. And that's because it's not associated with a term. Academic plan summary just looks at what academic program plan stacks does the student have. And within this, we can see what is the current status of any program plan stack that they're in. Specifically, if we want to find out students who are active in a program, this is where we go. It doesn't matter whether they're enrolled. We're just talking about do they have an active program plan stack? So within academic plan summary, right now we've got just a few facts, but the primary use of this subject area is looking at students and really what their status is in their program plan stack. And I'm going to go into more detail on all of these as we continue on. Term enrollment, we just talked about, that is the term enrollment of the student. But then when we get to class enrollment, we're taking it a step farther. So a student can be in term enrollment, they can be term activated, but they can never have enrolled in a class. And if they haven't enrolled in a class, they're not going to be in class enrollment. Class enrollment has the information down to the student's class level. So the kind of grain of that table would be the student, career, term, and class number. And then we get into the kind of the smaller subject areas, but I think they're still fairly heavily used and important. Academic course just looks at the courses themselves, the ones that are all offered at UC. So anything that's ever been offered should appear in academic course. We're importing STARS data, all of those courses are in there, but you can also see what courses are currently active or inactive, assuming all of that information has been set up in Catalyst. Then we move down to academic class. Academic class says we have this course. Now somebody orders the class exists in a term. So academic course, your integration ID is just essentially the course ID and the course offering number. But when you get down to academic class, we're talking about a class number and a term for something that would be the integration ID or the grain. Class meeting pattern, on the other hand, takes it one step further, and we're talking about a class and when it meets, where it meets, all of the different things that can happen. And then we have one really large subject area called class enrollment and meeting pattern. And what that does is that actually combines class enrollment and class meeting pattern in one kind of huge subject area. So I'll talk a little bit more about that as we move on. So academic plan summary. The GRAIN, as I said, student career plan, and then student CAR number. What that means is anytime a student gets a new student CAR number on their program plan stack, they're going to generate a new row in this academic plan summary. And subplan, because of the way we've set this up to allow us to see multiple subplans for every student CAR number, subplan actually breaks the grain of this subject area. What that means is we've set up a join so that you can bring in multiple subplans for an individual student, but that means you're going to create duplicate records when you run this report. So it's important to remember when you're looking at an academic plan summary, if you are doing something like summing the total number of student IDs you see, or summing the number of units toward a GPA, and you include subplan, it's possible that that subplan is going to cause you to double count things. This is especially important, and I'll kind of, when we get into doing examples, I'll note this. When we're talking about building a report and then we exclude a value from the view or from the actual table, when you do that, that doesn't actually take that column out of the analysis. All it does is makes it so it's no longer being viewed. And what we found is a lot of people, when they exclude things, they exclude something like subplan, those duplicates still exist in the report, and it will sum over multiple subplans, even if you can't see the subplan in the analysis you built. Term enrollment, we talked a little bit, or I talked about the grain here. Once again, subplan, because of the way we've set it up currently, it can cause duplicates. We don't really have a concept of primary subplan, and rather than try to bake that into term enrollment, we've used the same philosophy we used in academic plan summary. So again, if a student has multiple subplans, it can cause duplicate information. As long as you keep subplan in your view of your analysis, everything should work out fine. But again, we just have to be careful when we're working with the subject area to take care when we're using subplan. Other key important things, I don't have it necessarily listed here, but in term enrollment, you've got an enrollment status code. And it's very important if you're trying to count students who are actually enrolled versus students who are term activated, that you filter on enrollment status code equals E. E stands for enrolled, and that's basically just ensuring that you're only pulling back students who are currently enrolled in a class. The enrollment status E code is populated based on a student. If a student is enrolled in at least one class at the time that the data is loaded, they're considered enrolled. If they've dropped the class, even though their enrollment status code in like student enrollment is still E, in term enrollment, we've set it so when they drop a class, their enrollment status changes so they're no longer enrolled. And when I get to class enrollment, I'll talk about what that means there. But if you want to match numbers between term and class enrollment, the filters have to be slightly different. So class enrollment. Again, the grain, we're talking about a student, career term, and the class number. Now in this subject area, subplan is unique for each student. It's using the same logic that the financial aid term activation is using. It's pulling the lowest subplan alphabetically into the subject area. There's a variety of reasons for that, but the main one is there's so much more in class enrollment that needs to be aggregated on, including multiple subplans. We're worried would cause a lot of confusion and a lot of problems when trying to figure out how many units is a student, individual student taking. or how many people received a certain grade in a certain class. This ensures that for this subject area, you're only ever going to get one subplan per student. The kind of facts we have in this subject area, grades, units, student counts, they really lend themselves to a lot of analysis. One thing I will caution people on is the class enrollment subject area is a very, very big table. It's one of the biggest tables we have in our data warehouse, and the reason is for every student and every term, every class represents a row. So that table is big and it's going to grow very quickly. What that means is if you can do an analysis out of a different subject area and get the same data, you probably should use that other subject area in terms of making your analysis run faster. So if you are just looking to count the number of students who are enrolled in a term, you can do that in class enrollment. But unless you have to know something specific about the classes they took, you're better off running that out of term enrollment. However, if you want to know how many people were enrolled in a specific class or specific set of classes, class enrollment is where to go. Class enrollment is also where you go if you want to get something like a grade roster or just class roster in general. Class enrollment has that kind of information. So the other subject areas, oh, I'm going to go back real quick because I did forget one thing. Class enrollment. When we're filtering to find enrolled students in class enrollment has both an enrollment status code and an enrollment status reason. So the enrollment status code of E here still indicates enrolled, but a student who is enrolled after the last data drop without penalty will remain with an enrollment status code of E for that class. And the reason is that enrollment status code in Catalyst really is representing, are they enrolled in such a way that they're going to receive some form of grade? If they're still enrolled after the last data drop without penalty and then they drop, they're still going to receive some kind of grade, a W, a UW, whichever grade they get. So that means is you need to, if you want people who are actively enrolled and sitting in the class, not that all classes people sit in anymore, but if you're talking about people who are actively participating still in the class, you need to filter on enrollment status code equals E and enrollment status reason code equals ENRL. So that indicates that the student is enrolled, will receive a grade, and they are still actively enrolled in the class. When they drop, that enrollment status reason code changes to DROP for drop. So moving on to the subject areas that don't have student-specific information, but I think are still very useful. Academic course, as we talked about, has a lot of course level information. We can use that to double check and make sure that things that we've set up either through e-curriculum or anything we've done outside of e-curriculum for a course, does it look right? Does it look like we've built those courses correctly? Is the data coming over from e-curriculum correctly? All the attributes applied as they're supposed to be. And then when we get down into the academic class, that's where we get into things like, as you order a class, did all the pieces of that class order get put in correctly? Is there something missing? Did something happen? So academic class, we can look at the instructor of a class. We can look at the number of students who are currently enrolled, but also how many students are allowed to enroll. Did we set that enrollment capacity at the correct number? Did we set the instruction method, set the component correctly for that class? That's where we would use academic class. And then class meeting pattern, we take another step down. Now, class meeting pattern, we have to be careful. In academic class, it's very easy to look at classes, look at enrollments, add those enrollments up to get, I want to know the total number of students who are enrolled in math classes. So subject code equals math, put in enrollment, and it will add them all up for you. If you do the same thing in class meeting pattern, and you try to sum up those enrollments, you're going to get much larger numbers, because class meeting pattern for each class is going to have multiple rows for the class. If a class has been or is offered at multiple times throughout the semester, so they have one meeting pattern the first third of the semester, and then the second 2/3 they meet at a different time or different place, there's going to be 2 rows for that class. Also, when you get into classes with multiple instructors, they're going to have multiple rows for that class. So in class meeting pattern, we can get a lot of very detailed information about individual classes, but class meeting pattern is not a very good subject area for trying to summarize data about classes. So if we're trying to do operational, let's make sure I order the class at the right time and right day, class meeting pattern is a great place to look. But if we want to know, well, let's see how many people have been enrolling in this specific math class over the last 3 terms, or how many people have enrolled in this set of math classes, then academic class is where you want to look. Even if you want to go to the college level and say, how many people has arts and sciences enrolled, well, we need to go to the academic class subject area. And then class enrollment and meeting pattern is this combination of class enrollment and class meeting pattern to create a very large subject area that's really, again, only useful from an operational perspective. You really don't want to try to sum up things to aggregate within this subject area. It is, however, very useful if you have a specific subgroup of students, so say athletes or first-generation students, and you want to know, well, what times are those students taking classes? You know, these athletes are taking classes at times that conflict with their schedule. You can look and see quickly, given a set of students, when are their classes. This can be especially helpful if you just get a list of students, a list of IDs. You can use that list and paste it into a filter to see what classes those students are taking and when they're taking them. But again, duplication is a very large issue in that subject area, and we have to be very careful while working there. So now we're moving on to the scholar dimension. So within the scholar dimension, I think everybody who's been using CaRT kind of understands that this has all of the information that's, you know, inherent to the student. And inherent's really not the best word, but all of the information that is directly associated with a student or really anybody in Campus Solutions, in Catalyst. So one of the things we've done, and it's not obvious when you're working in the presentation layer, it looks like that scholar table is one table. But what we've actually done is we take one table, that's the scholar dimension, and then we link it to a bunch of attributes of that scholar. The attributes can cause duplications. So if we're looking at this kind of mapping, you've got scholar, and scholar connects to scholar contact. And this is really the most common case that we run into. Scholar contact has all of the information about contacting a student: email, address, phone number, what have you. And the way that this scholar contact table is structured, there is one row for every single address, physical address that a person has. But it also has your email addresses and your phone numbers, and those do not have multiple rows. So for a student's permanent address, it lists their permanent address and then also whatever their campus email is. For their dorm address, it's going to list the dorm address and that same campus email. What that means is, and it's not intuitive, if you bring campus email into an analysis, and you don't have either address in the analysis or some kind of filter to filter out only one of those address rows, you will get double counting on a lot of your facts. So within the scholar dimension, there is a best available locator indicator, and it's just a yes/no indicator. Anytime you want to use any value from Scholar that involves contacting a student, you want to filter on that best available locator value to ensure you're only bringing back one address, in this case, one email, without having any kind of duplication. One of the nice features about CaRT, which is also sometimes a detriment, is that CaRT automatically, every analysis, every table is a distinct analysis. So if you look at a table, every row that gets spit out is going to have at least one value that's different from every other row in that table. And that's great, except it makes it very, very hard to tell when this kind of duplication is happening, because it automatically rolls up the data into a single row when really there's two campus email rows in this case. So some of the other tables that are set up like this within Scholar, we've got the Scholar Advisor table, and somebody had a question about that. That's a new table we've added, and I'll kind of talk a little bit about how we can use that. But then we also have a bunch of Scholar attribute tables that say what sports, what NCAA sports is the Scholar currently active in, what name or names does the Scholar have. Currently, within CaRT, we have two names available. We have former name and we have preferred name. And we are in the process of working with the registrar's office and student affairs to kind of figure out what the best policy is going forward for other names that we need to include, because prior to Catalyst, we really didn't have multiple names within Universis. This whole concept of a preferred name versus a primary name, that wasn't really a thing. As we learn more and as we kind of do more with this, more names I expect will be added to the attribute. Citizenship status is also a Scholar attribute, and that's another one that can cause a lot of confusion. Every single person in Catalyst is supposed to have a citizenship status relative to the United States of America. So your citizenship status relative to the United States tells you, is this person a citizen of the US? Are they a permanent US resident? Are they a non-resident alien? So that's where you get those kind of statuses. However, if someone is a citizen of another country, China, Canada, India, they will have another row on that table indicating their citizenship status relative to that country. So a person who is a citizen of China but is a non-resident alien in the United States is going to have a row that says country USA, status non-resident alien, country China, status citizen. Only people who are citizens of non-US countries have records for those countries. It is possible for someone to have citizenship in multiple of those countries, though. So you could have 3 or more rows generated for that person. And we also are bringing in the accommodations information, and I have this labeled disability here, but really I think we code that as a diagnosis, the diagnosis code. So it's not just what we would think of as like disability codes, but it's any diagnosis that is stored in the Catalyst system. And then again, just to reiterate, all of these tables that are connected to Scholar can cause duplication because a student can have multiple rows in every single one of these tables. All right, so now I am to the kind of common questions and issues that we get, and this is not at all the only set of questions, but it's ones that we have gotten and ones that we received before this WebEx. So I'm going to switch over. I think everybody should still be able to see this. So the first one is, which units should I use? And this is one that's come up quite a bit because within Catalyst, we seem to store and have available more unit type values than at least I was used to seeing in Universus. So to give an example, I'm going to open up a new analysis. For those that don't know, this is CaRT. I hope everybody who's listening in has at least gotten this far in using it. So I'm building a new analysis in term enrollments. And we go all the way down here to the fact, expand that, and you can see that there are a large number of units taken, or units, I'm sorry. Just as a kind of side note, many people have figured this out, but if you have not, any item when you're looking in these fact tables, every subject area should have a fact table as the last table listed. And when you are looking in those fact tables, you'll see a lot of times the items have either a yellow bar indicator or they have this kind of white with stripes bar. Anything that has a yellow bar has some form of aggregation built in. So that means, for instance, units taken in progress, you don't have to create a formula to sum the units taken in progress. In this case, the units taken in progress is already set to do some form of aggregation. In this case, for units taken, it's going to sum all of the units taken for one row. But if you see a fact that does not have that yellow indicator, that means it's not designed to automatically aggregate. So in term enrollment, things like cumulative units, we don't want to aggregate because you can't add the cumulative units from fall of 15 to the cumulative units in fall of 16. It's a cumulative measure. So in fall of 15, it was a certain number, and in fall of 16, it is a new number. It's the number it was in fall of 15 plus the individual units that they took in fall of 16. I did some really good hand signals there to show everybody how that worked, but I don't think anybody can see that, so sorry. Similarly, cumulative GPA is not something we would ever want to try to aggregate on, but you can take GPA, or you can take grade points and you can add them up. GPA itself is a tricky one to add up because GPA, even in a current term, is really the grade points divided by the units taken for GPA. And if we start trying to average that, you get into taking averages of averages, and you can have lots of problems. So there's no defined aggregation for current grade point average. With that said, if you see a fact and you decide, I want to be able to aggregate on this, you can always bring the fact into the selected columns, click on Edit Formula, and then down here under Function, all of the kind of general aggregating functions are available here. So we can do things like sum, we can average, we can count distinct, we can take the minimum and the maximum. We still have the ability to do that. We just need to take care and understand that there's probably a reason why there isn't a default aggregation. So we want to take extra care and really think through what are we doing and what do we want to do. A good example of that is it can make sense to add up cumulative units if you're doing it within a term. If you want to know how many total cumulative units do all of the seniors in the math program have, you can add cumulative units in and change it to a sum. And then you can bring over academic plan code equals math. But now I have to be careful, because if I run this right now, it's going to pull everybody who's ever been in the math program and add all of the terms up. And I really only want people who are currently in the math program. So I'm going to do a filter on term. And now my aggregation makes sense because I'm only adding the numbers up within a term. And I get nothing comes back because I probably put the wrong plan code in. Let me see. Math BS. And we can see that currently people enrolled in the Math BS plan have 10,153 total cumulative units. If we wanted to filter that based on their academic level, we could look at just seniors. We could do some more kind of slicing and dicing of this data. So that wasn't the question we came here to answer. The question was, what units should we be using? Oops, sorry about this, everybody. So you can see here, we've got a list of units taken in progress, taken for GPA, taken for non-GPA, taken towards academic load, and then units passed in progress for most of those different values. We've also got units transferred and then total term units. In Universus, especially in the Universus data warehouse, we really only had two values. You had units, or you had credit hours that you were taking, and then you had the credit hours that you had completed. For our purposes, units taken in progress is the most equivalent value of that units, that credit hours that the student was taking. So units taken in progress is the one that I think we're going to want to use most of the time when you're in this subject area. Units taken in progress is actually a calculation that adds up the units taken for grade point average and for non-grade point average, and also the units audited. So it sums those three values, and we created a new value that's just the units that the student is taking in a given term. Units taken for grade point average is pretty self-explanatory. Those are the ones that are going to count toward their grade point average. And then the units taken for non-grade point average are the ones that do not count towards your grade point average. But then units taken towards academic load, this is where we get into things that we didn't really have in the past. Units taken toward an academic load indicates how many units are being used to determine whether the student is full-time, half-time, part-time. And units taken towards academic load most of the time will match the units taken in progress. The kind of main example of when it won't is when we're talking about a co-op course. So a student who's on co-op, that co-op class is 0 units. You know, they're going to get a pass-fail grade in it, but it's not going to add to their GPA. It doesn't really indicate any measure of time spent in the classroom. The 0 is just meant to be a class to kind of tell us that this student is out on co-op. However, those students who are out on co-op need to be considered full-time for a variety of reasons, but I mean, the main one's just, that's university policy. That's the point of being on co-op, is you're a full-time student out working. And in order to get Catalyst to recognize them as full-time, the class that they're taking is 0 units, it counts as 0 units in progress, but has a 12 unit, or if it's a grad, it'll have a 10 unit academic load value. And that's when this units taken towards academic load is going to be different. And then we have these units passed in progress, past 4 grade point average for non-grade point average. Those values are really what we are looking at when we're talking about like the credit hours completed. So if a student takes a 3 unit class, they pass it, they're going to get 3 units passed. But if they fail, their units passed will then go to 0. Units passed and units taken are going to be identical until grades are submitted and finalized. So if a student doesn't have a grade, the units passed in progress, the units taken in progress should be exactly the same. Units transferred indicates for that term the number of units the student transferred in. It doesn't indicate, what course credit they got for it or anything like that. It's just talking about this student had X number of hours of transfer credit in this term. And then total term units just starts adding up things like their units taken in progress and their transfer units and any other, like we have other units here. That's units that aren't transfer units and aren't test credit units, and aren't units that are taking at UC. That's just some other set of units that doesn't fall into the general buckets. We also have down here somewhere unit test credit. So that would be credits that they brought in for that term from some form of test, whether that be potentially an AP test, CLEP. It could be a specific test that allows you to pass out of individual classes. Those are going to be, if it's a test that's stored in Catalyst in the test scores tables and it results in credit, it gets stored in that unit test credit. So those are the main units that we would generally want to use. We also have a few more, especially down here when we have the financial aid units. Financial aid units is very similar to that units taken towards an academic load. It is just units that count towards a student's financial aid. So some credit that a student earns may not actually be financial aid eligible, and so it won't count on that list. The financial aid units typically are going to match the academic load units because, again, a 0 credit hour co-op class needs to count as full-time from a financial aid perspective. I kind of talked about this earlier. How do I return only enrolled students? The answer is it depends on what subject area you are in, but in term enrollment, we want to use in the enrollment status table, we want to filter on enrollment status code equals E. And then the easiest way, if you just want to get a count of students enrolled, is we go down to the fact table and we bring in term enrollment count. And now if I run this analysis, it'll say how many math BS students are enrolled in spring of 2017. And I run it and I get 56. I could go down to the scholar table here and bring in a identifier for a student, and I could get a list of those 56 students. I'm not going to do that here because I don't want to display a bunch of personally identifiable information if I don't have to. But just dragging over EMPL ID, for instance, and it would list 56 EMPL IDs, all with a term enroll count equal to 1. However, that's term enrollment. We go over here to class enrollment. We need to find the enrollment status again, and that code has to be equal to E. And then we also need enrollment status reason code is ENRL. I'll go down to the fact table and I'm going to pull over student enrollment count. And let's do the same math-BS. And I get 0. That's odd. I get 17,000 in overall, so either the math students haven't enrolled or there's something else going on. I'm just going to quickly drag over. And you can see the college data is coming over as you'd expect. So I'm not sure why the math BS was 0. Maybe I typed something wrong, but we can see how we get our enrollment count this way. So then this is kind of a conglomeration of a lot of questions that we get. But one of the big questions is, I've got 2 subject areas. They have some data in one and some data in the other, and I want to merge them together. How can I do that? The short answer is, if you want to display it all on one screen at the same time, you really can't do that. The tool that we're using does not allow for those kind of joins between subject areas because, and if we kind of go back to that model that we had here at the beginning, the fact table, that is the subject area, is that table that's right in the middle, and it's not joined to any of the other fact tables. When we do join it to another fact table, that's what we do to create something like class enrollment and meeting pattern. Essentially what we're doing is taking 2 subject areas and joining them up. Logically, we can do that for some subject areas and it makes sense, even though, as you know, as I've noted, that can cause a lot of problems with aggregating, but at least the data within those 2 subject areas makes sense. But that kind of logical creation doesn't always make sense and can create just crazy lists of data that don't really tell you anything because the 2 subject areas aren't tied together closely enough. With that said, we can do a lot of things about working between 2 subject areas to get the kind of information that we might want. Kind of the classic example is creating a subquery. So what I'll do is I'm going to build first an analysis that says in 2168, list all of the students who are enrolled So this is going to list all the students who are enrolled in 2168. And I'll save that in my folders. And then now I'm going to create another analysis. And say, I'm going to filter on spring. And I'm going to look at just the EMPL IDs of students who are enrolled in fall 2016. So we go EMPL ID, we go all the way down in our filter to based on the results of another analysis. And we want all of the EMPL IDs from that analysis that we created. We want them to be equal to the EMPL IDs that were filtering on. And I'll pull enrollment status code over to make sure we're just looking at enrolled students. And I will remove EMPL ID so I'm not showing any student identifiable information. But now we can see we have an analysis that basically is going to tell us, if we remember earlier when I ran this, we had like 17,700 total students enrolled. And what we can see here is that of those 17,710, 16,649 were also enrolled in the fall. So we only have currently about 1,000-ish students who were not enrolled in the fall, but are currently enrolled in the spring. Obviously, there's a lot more time until spring enrollment's done, so I would expect that number to go up as we get closer and we run some of the spring orientations and that sort of thing. But that's just an example of how to create and build a subquery, and you can string these together over and over and over again. So you can do, I want the students who are enrolled in fall of 16, then I want all of the students who are currently enrolled in fall of 17, like we just did. If I put EMPL ID in here, I could string that back and say, okay, so of the students who are enrolled in fall of 16, I have now a list of students who then enrolled in spring. Let's look back at all the students who are enrolled in the fall and how many of them are not in this list. So you can get a list of students who who were enrolled last term, but are not currently enrolled this term. And you can just keep stringing these subqueries together. The main limitation is this can really only be used for filtering purposes. We can't display their program in fall of 16 along with what their new program is in fall of 17 if they were to have a different program. So adding something to a delivered report and then also saving delivered reports to edit and play around with. So adding something to a delivered report, if you see a report that you like, but you really are like, oh, I would like this 1 or 2 things added. The first thing to do is contact the training team, and they'll contact the CaRT team, and if that data already exists, we can always add it to the report. And in general, we don't have any problem with adding elements to a report as long as it doesn't change the way the report works. That goes for prompts also. So if you say, I have this report, it's really nice, but I would really like to be able to filter it by whether or not these students are in a first-generation student group, or whether or not these students have a specific service indicator, we can add prompts for that to the report, even though it's not going to change the data that's in the report necessarily. It'll just allow you to filter it on the things that you are interested in. But alternately, and I think it's useful to kind of play around, especially since we are talking about a very new system. If we have a delivered report and we want to just see, 1, how was it built? And 2, what can I do to edit that report to do different things? I want to add something myself. To do that, we have to work within the catalog. So I'm here in CaRT, and pretty much anywhere in CaRT, you're going to see this global header. And at the top, there's going to be something that says catalog. So we click on catalog, and it brings up this list of stuff, my folders and shared folders. For most people, the shared folders is just going to have CaRT and side CaRT. But for the CaRT team itself, we have all these other folders that really don't mean anything. Within the CaRT folder, that's where we have all of our delivered reports saved, and the folders align with what the subject of those reports is. So for instance, if I go to the CaRT homepage, I go student records, university, and that lists a whole bunch of student records reports that are relevant to or can be used across the university regardless of career. And I've got all these reports, and I say, you know, I really want to see this student begin term report. I would really like to pull that report down and edit it myself. So we know it's in student records, and we know it's in university, and we know it's under the university tab. So within the catalog, we're going to go CaRT, student records, university, and then there's always going to be a library folder. And within that library folder has all the reports. And we can scroll down and find student begin term. And now, if you're just a regular end user, even with developer access, you can't edit this folder. But the reason you can't edit the folder is because of the permissions on the folder itself. And you can edit the items that are in your My folders. So what we're going to do is we're going to copy, and we can go down to More and click Copy. There's also a copy button down here, and this little icon up here copies. So we're going to click Copy, go to our My folders, and click Paste. And now all the way down at the bottom, and initially it will automatically show up at the bottom, but next time you return, it will be sorted alphabetically. We see the student begin term report, and I double click on this, and now you can see all of the specific pieces of the report. One thing, and we talk about this a little bit in the advanced training, this is important when you're talking about dashboards. In order to make the dashboard work the way it's supposed to. So this icon here indicates it's a dashboard. This one is an analysis, and that is the prompt. And you can see we've also named them so that an analysis starts with an A and a prompt starts with a P. But if we want to edit this dashboard, things get a little confusing because we actually have to relink these files up. Right now, this file right here, this prompt is actually the prompt from the CaRT shared folder because copying it doesn't change that link. We need to link it up with the prompt here. So you see that file exists there. So I'm going to delete this one, drag it up, drag the new one up there. Going to delete these two. And this is something that we do a lot on the CaRT team. I wouldn't necessarily say it's advanced, but it can be very useful. Is within a dashboard, you can click on the dashboard properties and show view, and you can pick a specific view to show. So in this case, we're going to have one section of our dashboard that just shows the title, and then this other section of the dashboard is going to show the table itself, rather than having one section that shows the entire compound view in the analysis. So now I've relinked them up. I can run it. I see the report. I'm going to go back. And if I want to edit any of these, I can go through the catalog to edit them, or I can click on the little properties and go edit analysis. And if there's something I want to add in here, I can add it in. So I want to see, I don't know, fill in the blank information. I want to add gender or ethnicity. You can easily just drag it, and now it's added in. Again, if it's something that you really want to see and you think would be useful as in the shared report, the best practice is to ask us to add it in also. But we do encourage everybody to go in, copy these out, play with them, see how they're built, because I think one of the best ways to learn the system is to use it. And that's it as far as the delivery questions. And it looks like I might have gone right to an hour, maybe a little bit over. So I guess I'll pass it over to Matt and we can start doing questions.
All right, I'm gonna go ahead and stop the recording. We've had a few people send in some questions um, while the presentation was going, so we're just gather those up, let Nick rest his voice a little bit, and proceed to answer those questions. Um, just wanted to, again, just to let you all know, we do offer open labs pretty frequently. The next 2 months with holidays is going to be a little bit of a different schedule, but just look on our website, go to Catalyst. If you go to uc.edu/catalyst/training, you can always register for an open lab just to get a little more hands-on help. Any other questions, you can always submit them to us, catalysttraining@uc.edu, and we will try to answer them. If we can't, we'll send them to Nick and his team to try to get those answers for you. So just give us just about a minute or so, put all these questions that we received, and I'll turn it back over to Nick. We also have some other members from the reporting team that maybe you may hear from as well. So just give us about a minute or so. Thank you.